Well, hi, good morning. Thanks so much for joining me here in my shop for another run at this radio. Oh my gosh, I'm down the rabbit hole some distance now. So just a quick recap. A quick recap got me into this problem here. Or did it? We don't really know. That's really the problem. I really don't know what's going on with this receiver. So I changed out 6 capacitors and the receiver hasn't worked since. I've reviewed those a couple of times. I cannot see anything at all wrong with any of the installations of the capacitors I put in. Oddly enough, I found another capacitor, original one, disconnected. That was just right here, which I spent some time trying to carefully make sure I connect it to where it's really supposed to be. I think I did that. The receiver still is an absolute zero. So I know the amplifier is amplifying. The receiver appears to be essentially dead. So I've decided I'm going to start some real basic troubleshooting stuff here, and start from scratch, and we'll see how this goes. So the first question would be, is there any power reaching this board? This is the board in question here, and I'll be surprised if there isn't any power, but you have to make sure. Now there is a lucky break in this receiver. I'm going to get rid of this antenna wire here. 12 volts going to this board makes a short stop right here in this filter arrangement, or whatever it is that they've got here. So the 12 volts is easily found right here. Quite sure of it. Let's take a look. We'll see what happens. Okay, so I got to power this guy up. Make sure it's not working. Okay, power's on. It's switched to AM radio, and the volume is up a little bit. Okay, power on. Okay, I heard the speakers pop, and there's a gentle hum in here now. 12 volts, 12 volts. We should find 12 volts right here. Ha! Ha! On the other side, I got it backwards. Is this meter really doing the trick? Here's a big capacitor here. Well, there's 18 volts there. 12 of it should be appearing here. Well, that's interesting. No 12 volts. I should look on the board a little bit, but I don't know really where to look, where exactly I expect to find something here. I can find dribbles of voltage which won't mean anything to me. I would want to find all 12 here somewhere. Or hear some noise. Well, the 12 comes in. Power off. Okay, I'm going to study the schematic a little more here. We're going to work our way up towards the power supply. I think on an earlier video I joked about the 12 volt output here, but now it becomes a test point for us to look for the 12 volts. Let's see if it's there. Nothing there. Just make absolutely sure here. And gain on this big capacitor. Yeah. No 12 volts here. Where did the supply voltage go? I turn the power off again and continue hunting on the schematic here. Okay, we're going to study the power supply here and make sure the output of the power supply really exists. So on the schematic, let me just zoom in. This is the power supply area here. I can just zoom in on that. Make it a little bigger, a little blurry. There we go. Okay, so these 3 capacitors here, big filter capacitors, a 1000, a 500, and another 1000. We're going to locate those. I've already done some preliminary work here. The power is switched off on this unit right now. Here's the two big capacitors there. You can see them up above. Big metal cans, nice looking capacitors. One of them has 3 sections, and the one in the back there you can't really see it, but it only has one section. It's 1000. This one is a 1000 capacitor. You can see one leg is right to the chassis here. This one up here has 3 terminals on it. 2 terminals are tied together. That's a 1000. One terminal free here is a 500. These 2 terminals put together is 1000. There's 1000, 1000, and a 500, and that's how they've done it in this radio for some reason. Now, if we look at the resistors out here, I say 82 ohms, 82 ohms, and if we look on the diagram here, very carefully, you see 82 ohm resistors right here. So where they connect together is this point. Now, if you look at the power supply outputs here, there's one here, they just 4.9 volts AC. This must be operating the lights. That's not a very high. I put in a 6.3 volt light. Okay. And 2 other outputs are here. One is this line and the other is this line. If we look at this one first. Okay, we've got the 2 diodes, we've got a big 1000 capacitor here filtering it, and where does this go? It goes up here and connects to output transistor and looks like driver transistor. Another, and that's kind of the end of the supply, and exactly the same thing will be down here. So what I want to say is that the supply basically ends right in this area here. So this part of the amplifier is supplied from this leg. The other, and it's at what voltage? I don't know. I don't know. There's no hint here. Now the other output, they draw this line. Let me shrink the diagram here just a wee bit. They draw this output line right through the middle of the amplifier schematic. Here's the first connection. It's picking up these 2 transistors. So what they're doing is they're feeding the very end of the amplifier off this line, but the rest of it they're feeding off of this line. And now my eye just caught something very unusual. This. Somebody hand wrote 68 in here. How do you like that? Okay, back to the power supply. What does that say? Approximate. Approximate. I have no idea why it says approximate there. Okay, but what we really want to read is the voltage on these 2 output lines, the one that's driving this part of the amplifier, and this line, which if we follow it all the way, which I didn't do, if we follow it all the way, it drops down, it starts at 20 volts, gets down to 16 volts, gets down to 12 volts, and from there, look, heads up into here. So we know the 12 volts is missing here. And I'm at the other end now looking to see if a starting voltage right here exists. So the simple way of doing this is to check all 3 of these capacitors and see if there isn't voltage on them. That's the easiest thing to do. So that's what I'm going to do here. Okay. Let's power on. The negative lead we want it on the chassis here. Okay, checking. Now that's pretty interesting. I checked for voltage on this capacitor. This is a capacitor dealing with the audio output, but it has on one side of it voltages from the amplifier. From that output I showed you going to the output end of the amplifier, and that's why we see voltages here. Okay, so we know that part of the power supply is working. Now the other part, I should check all the positives on these. So here's one. Okay, so it's more than 20 volts there. .44 volts. 23 volts. 14 volts. So, okay, they're there. They're there, but they're not here. Why not? Somewhere between here and there. Okay, so this travels through the amplifier. Well, on the schematic it travels through the amplifier. In reality, it's just a piece of wire coming from somewhere here. Coming off of the, I still have the schematic. Oh yeah, schematic's up there still. Coming off of the 500 should be 20 volts on the 500. I believe that would be this. 14. So this is suggesting a shorted component. If this is supposed to be higher, and it's not, it's suggesting a shorted component, pulling down the voltage. We need to get somewhere in between this point and this point. Somewhere in between there. So on the schematic, we're talking about a point. Well, this is showing it as a terminal. Yeah, so I have a resistor here. It must I don't know what they're doing here. It's a half water. Can I find this spot? Because from here it's through the switch and then I think right to this point, which I test as 0. So we have to find this point. There's that contour control. Maybe this has something to do with a cartridge you use in the record player. Change the, that's what contour has to do with. So maybe I can find this. Half watt, 56. Why did they show it? Like they don't show any component. Where's a component to component connection here? Just 2 components in a row. So I want to see how they show it. Everywhere there's a dot. Absolutely everywhere they put a dot. I put a dot here. Till way out here. Is this a terminal strip? It's numbered. It's numbered. This is numbered. This is outside the board and it's numbered. 4, 5, 6. Of course, the one I'm interested in, they didn't bother numbering. This would be 4, 5, 6, 7, 8, 9, and 10 are somewhere. A terminal in this contour switch is wired up into this area. How to find this spot? I gotta find this resistor. I think it's on the board. This is on the board. That's the end of the resistor. This has to be on the board. 56, looks like 56 ohms, half watt. Okay, 56 ohms, half watt. 56 ohms, half watt. It's likely to be right on this board. Oh boy. It's likely to be impossible to spot. Hey, this is still on. Turn it off, Jim. Well, that's tough. Most of those resistors are tiny, quarter watt, half maybe. Well, there's a half watt resistor with a coil around it, right in here. A larger resistor rather with a coil wrapped around it. A lot of coil. It's just not going well. I don't see any other large resistors in there. Shoot. Okay, let's go back here. Maybe it's not on the board. 56 would be starting with a green, wouldn't it? And the green is 5. Any green resistors here? There's green there, but not starting with the green. I'm just looking all in this area. Here's another terminal strip. Doesn't have any components on it. This one's loaded with components, including the one I was monkeying with. Well, it's another fine mess I've got myself into here. I'm going to have to just spend some time studying this myself. Otherwise, it's going to be a very quiet video. Okay, lots and lots of studying to get to this point. So if we follow this power supply line, 20 volts here, 20 volts, yes, there's 20 volts on this wire. Come to this resistor. I managed to find this resistor and test it. It's 81 ohms. I'm going to assume it's conducting. We come along to here. Now we're at 16 volts. We encounter another resistor. This one I'm unable to test because of its position on the circuit board. I can't get test leads on it easily. So we can be pretty sure that there's 14 volts on this side of it. How can we be sure of that? Simply because I know this resistor is good. 14 or 16, maybe that's 16. On the other side is the 12. And the interesting thing is, the other side of this resistor connects right to that terminal, 12 volt terminal on the back of the set. So I can read, so I've already read it once and I got nothing, didn't I? Did I get a 0 here? If I get a 0 here, but I'm getting voltage here, it's that resistor that has gone open. Just a funny coincidence that in the middle of this work, this should happen. That's what this will boil down to. So I'm going to look for the 12 volts again. And then I'm going to have to try to get this resistor out or verify that there's nothing on the other end of the resistor. That there's something. If there's voltage here, then we know it's this resistor. That's what it's come down to. So we're going to look for the 12. I'm going to try to look for this voltage on one leg of this resistor. One leg I can get a probe on. It's the other leg I can't, I think. Anyway, that's what we're going to do. Okay. And really, it's really been challenging to find these parts on the board. To me, it's a little like going for a walk in the woods, and you're following this path, this kind of circuitous path. You're wandering around in the woods, and at some point you look down at your feet and you realize, I'm not on the path anymore. And you're just lost in the woods. And that's what happens to me when I do this kind of tracing. I can get 4 or 5 components in, and then it's too much in my head to hold in my head. I start losing track. Sometimes I can't even remember why I'm doing things. Yeah, that might have something more to do than just the radio. There might be some factor inside my brain that's challenging me here. Okay, so we're going to turn the set on. We're going to look for the 12 volts. We can't find it here. I'm going to try to pick it off on a resistor way down in there and see if we can see it on one leg of the resistor down in there. So I'm going to clip this guy to the chassis here. Voltmeter. Okay, set the voltmeter to 20 volts because we're looking for 12. Okay, meter in view. Yep. Okay, so we'll switch on. We'll test the meter. Switching on. Okay, testing the meter. Yep. Now, well, that's interesting. Yeah. Never mind. Forget all that. It's not interesting. We are looking for 12 here. There's nothing there. So it's 12 where? I can't quite see. Down here. No 12. So now I'm going to try to poke the resistor that's dropping the 12. And this is really, I'm going to get a shock here for sure. I can get my fingers up in here if I'm not careful. You can't look in 3 places at once. See? I touched something there. So, you know, you're not supposed to do this anyway. You're not supposed to be connecting and then disconnecting on this kind of a receiver. I should put some kind of clip lead in there. That's not possible. Where are we at then? Are we absolutely convinced that that resistor? Hey, what about the other resistor? Now, the other big resistor, I've lost track of it. It's 82. It's this one. So we're going to go on the far side of this one. I can get at it, I think. This is the one I was able to test the... there we are. I see a voltage. 5. That's not right. That's not right at all. 5.7. 5.7. Let's turn the set off. The other side of that resistor is supposed to show 14 or 16 or something like that. So that's suggesting we need to look at the schematic some more. I'm gonna put it on the big, put on full screen here. So what I did was I just measured right here. Whoops. This side's 20. This side appeared to be a lot less. Yikes. So that would suggest something is pulling it way down here. Doesn't really explain a 0 on this side, a complete 0 over here. Well, that would mean that the short must be here on this line. Wouldn't it mean that? That this part's being pulled down? The only way you get a 0 here is to have a 0 here. Unless you have a short circuit out here, which I doubt. You have a short circuit out here? Well, that would make this 0. That would make this hot. Make it hot. I wonder if I should bring in my thermal viewer on this and look at these resistors. But when I measured this voltage, I didn't get 16. I got 5 or something like that. So a short, pulling it down would be, for instance, pulling it down to ground. Just looking at this part of the circuit. Short here. No, because of this guy's protecting. Oh, it's hard to say, isn't it? Shorted transistor. Don't want that to be the case. But that's definitely a possibility here. Got a large capacitor right here, electrolytic. Wow. Okay, so here I've changed a bunch of capacitors. The set's not working, and now I'm looking at, should I just go ahead and change a bunch more? Yikes. I think it's smarter to solve the acute problem here before dealing with the chronic problems. Because I don't know that it's I don't know that. What I'm jumping here without saying is I'm thinking one of these electrolytics has shorted. But I have no reason to believe that. Look at this one. This one right here, if it were to short, it'd be pulling things down exactly as they are. Well, that would mean if I read the resistance to chassis of this line, I would find it shorted. That's what I should really do. Get on this line. This line is connected to these capacitors. Maybe I can find these easily. It's a 10. So okay, where are these located? C10, C110, and C126. I'm way in the woods here. C110 and C126. Let's see those. C110 and C126. C110 and C126 and 110. Here they are. They're easy to find. They're on the edge of the board. And then I want to check on the positive side of these. No. Well, see, I'm lost in the woods now. Why am I even checking these? What am I looking for? I'm looking for a short on these. Yes, a short. Wait a minute. Is this supposed to go to ground? This isn't grounded here. Let me go back. Sorry, the wood. I got lost in the woods. Oh my gosh, I'm really. So this line was this guy. Short on them. That's not going to put a ground on. But it would mess things up pretty thoroughly. I wanted to measure this. I want to measure this to ground. Well, the only way this can get to ground is, it's got resistors here. No, this one. This one could do it. Okay, we gotta find this guy. C1, yeah, something like that. C something. It's in the midst of all these capacitors. It's the only one of its kind, and it's really on this line right here. This is the guy. This will be the guy. I'm almost ready to bet a quarter on it at this point. Gotta find this guy, C120 something, 16 volter, all on his lonesome. And that must be the size there. Yikes. What a drag. He's in between all these transistors here. Okay, so that would be C1 something in amongst all these transistors. And this is Q, give me a number, Q, well, I've written way up here, down here. So 112, 111, 105, 106. Look for, since they show it this way, look for 112 and 111 and some big capacitor in that area. 112 and 111. 112 and 111. 112. Q, what is this? 2. 1. 112. 112. What's happened to me here? Q112. And I put a number on. Oh, Q104. 110. 112's not on here. It must be over here. Oh, here we are. 112. 105, 106, 111, and 112. Big capacitor right in the middle here. C128, 125. And it's like 12 volts here. This is 12 volts being taken off this board and heading somewhere else, actually. So this is the resistor in question. There is no 12 here. We got to get on the positive terminal of this capacitor, which is located, it's a large guy in between these 4 transistors arranged in this direction. Okay. Okay, I think I got it. Okay. There's the great big capacitor right there. Right there. Right. That big blue one there. That's a guy. So the idea is on the positive side of that capacitor should be 12 volts. Isn't that what I figured out? Didn't I figure that out? Now getting down in there is tricky again. I don't know how I'm going to get in there. Son of a gun. See if I can get one of these to grab onto it. Okay, right there. Oh, I almost had it. Got it. Okay. I think I got it. Okay. So we're going to hook up the meter to that. Okay. Hook up the meter. Okay, I may or may not be on there. I may have shorted parts together. I don't think so. Okay, I think I did it okay. Looks all right to me. So the question is there 12 volts there or something? Here we go. There's that low reading, 5 volts, the low reading. Okay, so what we just did was we tested here. Found a low reading here. The nearest, so what is it that goes to ground from here that would pull down the voltage, potentially heat this resistor up? Wait a minute, it's the other way around here. So it's almost as if this is filtering the takeoff that's heading for the other board here. Could there be something? So I'm reading 0 here. This is where the ground is. Yeah, that's what's happening here, is the ground is off on this wire somewhere. So we need to follow this 12 volt wire back into the other. We need to test this and see if there's a short. We need to test this and see if there's a short. I'm going to say that again. Anywhere on the 12 volt wire. Oh, okay, that's easy. Anywhere on the 12 volt wire. Right. Okay, so we're read a short. Is the 12 volt circuit shorted? Oh my gosh. Is that a short? Yeah, so my 0 right now is 0.3. There's a short on this line. That's what's happening. Okay, I got somewhere. I think I got somewhere. Why is there a short on that line? Why is there a short on that line? Okay, looking back at the schematic again. So now we've determined that there's a short on this line, and it's not up in here. It's got to be on the other board. So we go to the other board and try to find this. 4-inch green wire. 4-inch. Oh, it's much longer than 4 inches. I don't know what these measurements really are. 3 inches to the ground. Okay, but I do know where this wire goes. It goes quite a distance. all the way up into this board. Do they show a green wire coming in somewhere? This must be the feed. I'm going to guess this is the feed to the FM lamp right here. I didn't think it would say FM lamp though. Okay, going down here. Should be like a 12 volts coming in wire. A 12 volts coming in wire. AM FM board. Oh, here we are. 12 volts coming in wire, 4-inch red. Green, 4-inch green. So these are probably going to a terminal of some sort, or something's going on here. Something is going on here. So if we follow the 12 volts on the far side of the resistor here on the circuit diagram, 127. 127. Try not to lose it, Jim. 127, and it's getting awfully small on your screen, I realize that. 127. I'm lost in the woods again. All the trees look the same from here. 127. Okay, I gotta go back. I have to go back. Find. Oh my God, this is on R127. Right. The half watt 56 ohm resistor. Right. I remember where that is now. It's right here. Half watt 56 ohm resistor. We follow the wire. Here comes the wire, and the wire. Oh boy. It just goes everywhere. Oh boy. I mean, it could be a short circuit on any of this. It's most likely a faulted component though. Oh boy. These switches, you know, it's enough. I don't need these switches to increase the frying temperature of my brain, but they will, definitely. I would have to print this out and color these lines and trace this whole thing through in order to sort it out. But we know the 12 volts arrives up here, right here. We know this. So we know it's coming through here. We know it's on this wire. We know. Well, this is kind of interesting how they have this arranged. It's AM, AM. Reverse, mono, AM or FM. AM, what's this? Is this gang together? AM, FMX, AM tuning meter. What the heck is this? How many switches are there on the front of the set? There's 1, 2, 3 and down the side there. So we have, that's on the other side. This is 1. This is 2. This is 3. What is this? It says AM. Oh my God. Is there another switch on here that says AM on it? Where's the cover? Is there another switch that says AM? So I'm looking. Oh, there's the line. You're looking at the small size here. I'm looking here. AM, that's the only place AM occurs. 3 switches. Oh, what are they trying to pull here? This kind of thing here. I'd zoom in on it, but I'm really not going to study through these switches. I think we can just deduce the 12 gets through the switches and appears, supposed to appear, up here. Now, what if I look for a short and operate all these switches? I'll put the meter back on the 12 volts and the short. Okay, right. Let's do that. Everybody following me here? Okay, now power is off, so I can operate any switch I want, like the power switch, like this switch here. I'm just watching the meter, looking for anything to happen. Okay, so now we're going over to this is on the AM, and this is FM, this is neutral, and this is that, and that's this, and this is over here, and that's over there, and there's nothing happening. What if I do them all at once? Do every combination you can think of. How about these other switches? How about this one? Nope. How about this one? Nothing occurring at all. I'm out of switches. I'm out of switches. Well, that was a little exciting. That was the on-off switch. I think it's just a coincidence. So what does that prove? So we have a short that seems to have nothing to do with the switches or the switch positions. Now that's kind of interesting in itself too, because you could assume when this set is switched to phono that it's possible the power, the 12 volts, is cut off from the radio. So when I'm silent, while I'm thinking, well, do I need to have something plugged into the set here I don't have plugged in? No, I've operated it like this. Yeah, lots of humming, lots of humming. Some hemming and hawing in here too. Just for interest's sake, I've noticed that this capacitor is leaking up here, leaking something's going on anyway. Some chemical thing is going on up here. The set does have a low level hum. This is the kind of capacitor that would cause it. Oh my gosh, I'm standing still. I am moving. I'm no longer moving forward even. Yeah, I'm gonna stop the video and take a break. Well, I got a fish on the line now. I spent a long time troubleshooting and thinking and tracing and stuff like that, and I think I found something, so I'm going to show you what I found. So first of all, this 12 volts is missing, and if you put an ohm meter on here, it basically reads 0 ohms to the chassis. The 12 volt line attaches to this bus, of course, and goes everywhere into here. Oh my gosh, it could be all kinds of stuff that are shorted, but I said to myself, what is there that I did on this that could cause a short? And I got interested in this capacitor for false reasons, but I got interested in it anyway, and I found it on the board and replaced it. This is the one I piggybacked 2 capacitors to achieve this particular number, 125 microfarads. There's really nothing wrong with the capacitor in that, and it's even a false idea that this could be the cause of the problem, or is it? I started looking at the solder job around here, and that's what I'm going to show you next. It's a very, very tight space up in here. It's right up in here. You see, it's right beside this coil, the frame, this ground lug. It's right in there, and because I do not have easy access to a close-up camera right now. Yes, I do. Let's take a look with what I will call a close-up camera, because it's going to get close up. Yeah. This is a big camera. I can't shove it in very far like the other one I had, but I can still get in far enough to look at that. So, pretty much center of the screen, you see a couple terminals soldered together there. One of them is carrying the wire from the capacitors. Can you see the trace on the board? It's pretty obvious those things should not be joined. That's putting a ground on the 12-volt supply, right there. So I'm going to resolder this properly. I looked at this once or twice previously, but it's very hard to see, and I missed it. So I think this is all it is. It's just I did a bad solder job in this tight spot, exactly where you expect a mistake to occur, frankly. So, okay, I'm going to fix that, cross my fingers, and we'll see if the radio comes to life. Okay, let's take a look at it now. Well, you can clearly see now, yeah, I shorted right across it. Oh, what a dumb move on my part. I left a long tail of wire, but it's up there where it won't do anything. I think that's it. I think that is the problem right there. Okay. Just about time to start it up again and hear this guy work. Hopefully that didn't burn out any parts. It appears everything I tested was okay. It's pretty funny, while I'm hunting around for a problem, having trouble finding it, it's causing me to examine the receiver all over the place, and I found that broken off capacitor in here. So even though this journey should have been a lot shorter, this last part here, I should have really encountered my mistake sooner. I managed to find another problem while I was out wandering around in the woods. So there's some value there. Oh my gosh, it's afternoon. We got to test this guy. I got to get out of here. Okay, we're going to put an FM antenna on it. That's how positive I'm feeling. Well, we're putting a wire on where the FM antenna is supposed to be. Okay, speakers are almost coming out here. There, that's better. I'll hold it in there. Around we go. Okay, quick safety thing. What safety thing? This thing. I left this in here. Okay, that comes out. Very good. Volume down. Switch on AM. Power switch off. Everybody stand back. Okay. Smash the microphone. Ready. On the power. She's not turned on. There we go. There it is. By gory gosh. Balance control has an odd effect. Well, it's because it's not the balance control. Thumbs up. Okay. I'm done in here. Thank you. Thank you, universe, for helping me find this problem. So, wow, my own making, of course, of course. Okay, well, thanks for watching this video. Then tomorrow we're back to trying to sort out, maybe change some more capacitors, get myself into another jackpot, and carry on from there. We'll see you on the next video. Bye-bye.